Welcome to Chemistry 101 at Goodwin College. This week's unit is Unit 11. Unit 11 covers Chapter 10 in your textbook, and Chapter 10 in your textbook covers organic chemistry. So from this point on, the course becomes less mathematical. There are fewer formulas to remember. Doesn't mean that it becomes completely non-mathematical. There will still be some math. However, it's substantially different and probably a little bit easier than the previous portions of the course. So that being said, it can still be a little bit strange to students who haven't been introduced to organic chemistry before. So if it seems a little strange throughout this unit, I think you'll eventually get used to it. And eventually, beginning with organic chemistry, the course becomes more biological, although it may not seem that way in this unit. Before we start, we need to review a little bit about things that we had talked about much earlier in this course. So on this slide, I have 3 different molecules listed. There's this molecule over here that has a carbon in the middle and these 4 hydrogen atoms attached to it. There's this molecule over here, which is 2 oxygen atoms attached to it, and this one over here, 2 nitrogen atoms attached to each other. The question that I typically ask my on-ground students at this point is, what does this solid line mean? And you can pause and think about that. If it doesn't ring a bell, we covered this earlier in the course. The solid line is basically chemistry shorthand for a covalent bond. What that means, what this particular solid line means, is that this carbon atom and this hydrogen atom are sharing a pair of electrons, which is what a covalent bond is. And so this carbon atom here actually is sharing a pair of electrons with 4 different hydrogen atoms. And that's sort of how we are representing this particular molecule here. Carbon in the middle, 4 covalent bonds to hydrogen. This one over here, I would ask the same type of question to the students, and you can pause and basically answer what type of bond is shown here. And it is a double covalent bond because that's what the 2 solid lines mean. So 2 solid lines mean a double covalent bond. 1 solid line between 2 atoms means a single covalent bond. And then here, finally, this should be pretty clear at this point. These 2 nitrogen atoms are attached to each other by a triple covalent bond. So they are sharing 3 pairs of electrons. These 2 oxygen atoms are sharing 2 pairs of electrons. And this carbon and this hydrogen are sharing 1 pair of electrons. But every time you see a solid bond, that is 1 covalent bond. Every time you see a solid line, that's 1 covalent bond. 2 solid lines, double covalent bond, etc., etc. And that becomes important for this unit. So I want you to become reacquaint yourself with this type of drawing. So that's the end of the review. As you can see, not much to review from the past. Hopefully you have that under your belt. Now on to organic chemistry. So the word organic, usually I pose this question to the class, to the online class, and I say, what does organic mean? And just to be cute, I basically say we're not talking about the grocery store definition. I say we're not talking about Whole Foods and charging triple what you would pay at Stop and Shop or something like that. The word organic has a very specific meaning in chemistry. What it means is that you are talking about molecules that are made at least partly of carbon atoms. So organic molecules don't have to be made exclusively of carbon atoms, but they have to have at least some carbon atoms in them. Usually the types of organic molecules that you deal with, so they have carbon atoms in them, usually those carbon-based molecules also have a lot of hydrogen atoms attached to them. So that's another common feature of organic molecules. Again, they don't necessarily have to have hydrogen attached to them, but very often they have a lot of hydrogen atoms attached to them. They also can have these types of atoms attached to them as well. Very commonly you will see oxygen, nitrogen, phosphorus, sulfur, chlorine, bromine, and these others, fluorine and iodine as well. So these are atoms that are also very often attached to organic molecules that have carbon in them. Another feature of organic molecules is that the atoms in organic molecules are attached to each other by covalent bonds and not ionic bonds. And this is one of the reasons that I showed you that review on the previous slide. I was talking specifically about covalent bonds, and organic molecules have carbon atoms in them. They very often have these types of atoms in them, and the atoms, when they are attached to each other, are attached by covalent bonds. So usually you do not see many charged atoms, many electrically charged atoms in organic molecules. Uh, Organic molecules are usually not very water soluble. What this means, in case you don't remember from earlier in this course, organic molecules tend not to dissolve very easily in water. Even though they don't dissolve easily in water, they are important for life. And since we are primarily made of water and organic molecules, even though they're not very water soluble, they must be at least a little bit water soluble in general, because most of the molecules in our body that are not water are actually organic molecules. They actually need to be at least a little bit able to dissolve in water for us to be able to live. So, organic chemistry, I want you to realize that organic chemistry is a very large field in chemistry. So there are probably hundreds of thousands of organic chemists around the world. The organic chemists are basically people who study carbon-based molecules, people who study the types of molecules that I have described on this slide. It's a large field in chemistry. It tends to have a lot to do with biology, because many biological molecules are organic molecules. So many of the molecules in your body are carbon-based. There's the sort of opposite field of chemistry is called inorganic chemistry. So the "in" there basically means not organic chemistry. This is basically just to give you a sense of what inorganic chemistry is. This is the study of chemicals or molecules and atoms that don't have carbon in them. So basically everything else. Table salt is an inorganic molecule. And so actually the first portion of the course, the portion of the course that we have just finished covering in the previous units, is basically primarily an introduction to inorganic chemistry. So we talked about salt a lot of the time. We talked about a lot of things that people study when they study inorganic chemistry. So I just want you to have a sense of those two separate fields, inorganic chemistry and organic chemistry. So this marks the end of this section. This section was basically just an introduction into what organic chemistry is, what organic molecules are, and a brief review of the types of information that you need to know. You need to be able to look at those molecules that I showed you on one of the first slides that shows you covalent bonds between atoms.